We're going to look at a couple of the ideas in chapter 4, and so I thought I would go to a problem in your homework that would kind of show how StatCrunch can calculate some of the values for you. If you're having any questions about what the values stand for from the readings, please let me know. So here's our data. We have our x values and our y values, and we're going to determine the least squares regression line, also known as the line of best fit. So I'm going to open in StatCrunch. And to compute the line of best fit, I would go to regression and simple linear, and then I would just tell it which is my independent variable and which is my dependent variable. When I do this, I get a lot of information. I get my correlation coefficient, which is what section 1 is talking about, and it's a 0.977, so maybe that's good enough. I get my equation of the line, which is right here. There is my y-intercept, and here is my slope, and they state that again down here. So my slope is the 2.3108, and that's multiplied by x, and my y-intercept is, so when x is 0, my y value is negative 1.838. Also, I get a picture, so I get a scatter plot of the data and the line that goes through the data the best. So this is our line of best fit. So it gives us some good information just by going to stat, regression, simple linear, and we just have to choose the variables. Again, x is our independent, y is our dependent, and compute. I want to look real quick at this correlation coefficient. Is this strong enough? Like, the closer it is to 1 or negative 1, the stronger linear relationship it has. But I just wanted to show you in the book where they talk about how well does it fit. And so you should have tables in your book. If you have a hard copy, there's actually like a trifold you can pull out. If that pops up, there we go. But also in your book under Appendix A tables, there is a critical values for correlation coefficient. And so let's just look at that for a second. And we will notice, let's go back to StatCrunch real quick. We had an R value, a correlation coefficient of 0.977, right? We had 5 data points. When we go back to that appendix, for 5 data points, my correlation coefficient better be higher than 0.878 if I'm going to say it has a linear relationship. I was at 0.977, 0.977, which means I can say that there is a linear relationship. If I was below this number, then I would say I do not have a linear relationship based off of the number of data points. You can see the more data points you have, your correlation value doesn't have to be that high to say that there is a linear relationship. Also, let's talk about negatives. Let's say it was a negative relationship and I got a value of negative 0.977. Going back to the table with 5 data points, we look at the absolute value of our correlation coefficient. So I wouldn't look at the negative 0.977. I would just say, is 0.977 bigger than 0.878? If it is, there's a linear relationship. So again, the closer you are to negative 1 or 1, the better linear relationship the two variables have with each other. Hope that helps with section 1 and section 2. And then also to calculate your r squared value, it's here as well. It's just your R value squared. Gives you your coefficient of determination, which they talk about in section 3.